Hi, this is Hastings. Here, we would like to introduce PyIdentify, the classification with p-value. The Hastings, Yiqing Gu, Xiaoxia Zhang, and Professor Hayes will work on this project. What is classification? What is p-value? I'm going to explain later. So Professor Hayes gave us such an idea, and Yiqing will work on the coding part, and Xiaoxiang will work on the mathematics and statistics part. What is a classifier? A classifier is a machine learning algorithm that is trained on a data set to categorize or label data into predefined classes or categories. It learns patterns from the training data and uses these patterns to make predictions or decisions about new data. So how to create a new classifier? In the following graph, giraffe and elephant pictures are used here. We use photos as a dataset, and then we start machine learning for training purpose. After training, a classifier will be generated. It can predict whether a future input is a giraffe or an elephant. But classifier is not perfect. There is an edge case here. In the following picture, we train a classifier with dog and cat pictures. So what will this classifier predict? The answer is always a cat or a dog. It will not be a panda. This is an issue the modern machine learning usually have. If you give an image, which is completely different from dataset, classifier will give a totally wrong answer. That's why we started our project based on this problem. We would like to develop an API called Identify to distinguish given input image. There will be two scenarios after using our API. If given input can be categorized into training sets, that means prediction works correctly. Our API will do nothing with it. But if input image deviates from training sets a lot, we will make classifier stop prediction. And here, we also import p-value. What is p-value? P-value is a statistical measure used to determine the likelihood that an observer outcome is valued to measure the distance between training clusters and test points. So here, we're just gonna use the p-value to do comparison. If p-value is too big, we're gonna say, hey, this classifier does not know your test image or give input. So how this API works? The right picture is the whole workflow of our PyIdentify. But no worries, it can be divided into three different parts. The first step is data processing. We're gonna just turn all of the images into numerical data. And then we're gonna generate p-value. The p-value for each class, like cat, dog, or panda, giraffe, elephant. And then we're gonna just make a prediction. We have these p-values, and we're gonna do the comparison among these p-values. If the value is too big, we will say, hey, the classifier does not your given input, or vice versa. So why do we need this API? The thing is that the problem has been there for years and hasn't been solved for a very, very long time. No solution to this issue yet. We want to offer a groundbreaking solution to this problem. And then we would like to make our API automatically calculate all of the data calculations and processing all of the numerical data. You don't need to worry about, hey, I need to import a lot of different modules or packages. No, you don't need to do that. what you only need to do is that just to import our API, and it will help you to finish the rest of things. And the last thing is that we really would like to minimize the need for manual intervention in the validation of classifier results. That means the old or ordinary classifier will generate wrong random guesses. But here, within this API, you can just wait. You don't need to delete or remove or wrong random guesses after using your classifier. So here, the target user will be scholars. And this project will be non-commercial project. It will be open source. You can find it on GitHub. So we did some investigation. Before use normal classifier and after using the PyIdentify. The bottom left chart, you can see the time use on results. Normally, users gonna use 30 hours or more on normal classifiers because normal classifiers can generate wrong predictions. But with PyIdentify, users normally use like 15 hours on checking the results. So that means that 1/2 of the time they used before. And we also asked some scholars, we asked 100 scholars, what do you think PyIdentify is necessary? So 88% of them, they agree that right now they really need such an API to help them to boost their research. So there are two charts. The left chart is before using this API. The right chart is after using this API. You can see the random guessing becomes none above. And you can just save 30% of time on average for data processing. And that means usually it can help you save 1 or 2 hours and make it to finish your result check earlier for the data processing or the data checking. So the next step, the things we will move forward, we're gonna support more sigmoid functions. So sigmoid functions is a part of the data processing. If we have more sigmoid functions, that means we can just make API work more efficiently and more precisely. And then we're gonna optimize the working efficiency because working efficiency is always what we are focused on. Working efficiency can also help scholars save a lot of time on data processing. And then if possible, we're gonna develop a friendly user interface. Right now, it is just API. What you will do is just that to tune some parameters and to make it more straightforward. Thank you very much. I hope PyIdentify can be an industrial leading API to help scholars boost their research and enhance their efficiency.